Hi everyone. Are you having a good evening so far? Great, thank you. All right, so this talk is about API and ABI versioning. Basically, it's about how do you handle compatibility with your C++ libraries. When I mean your C++ libraries, I mean how do people stay compatible with the library you write? Like, the big question is, when I change my code, I'm a library maintainer, let's say, and I change some code in my library and I push it on GitHub, I release a new version, what are the impacts? What will the users experience if I do this? Will they have to recompile? Will they have to change their code? Will they get some nasty surprises? What exactly will happen? So we'll first talk about changes and how they impact both the API and the ABI. If you're not familiar with the ABI, don't worry, I have a quick introduction just before we delve into the subject. Then we'll try to categorize the change because it's important to make the difference between a breaking change and a non-breaking change. It does not have the same impact. Then we'll see sometimes if we can mitigate the impact. Some are unavoidable, but there are changes that you should be worried about and some changes that can be mitigated to have less impact than you usually thought. And finally, we'll see how do you handle that through versioning, to advertising the changes through versioning. So my name is Mathieu. I work at Murex in Paris, in which I also host and co-organize the French user group. If any of you is coming to Paris at some point, do not hesitate to drop by if you want to make a talk. Again, we will be very happy to see you. These are my personal contact, Twitter, and my recent blog, where I lately mostly talked about build systems, but promise I'll talk about something else too. So, talk about the library lifecycle, because when you start writing a new library, well, that could be overwhelming if you start thinking about versioning and about releases. There are lots of questions you can ask yourself. So I try to summarize which one are pertinent to the subject today. First one is, will all the users of the library belong to the same repository? For example, if you're doing like a company project and that everything in your company is stored in the same repository as some company do. Well, first of all, versioning is not mandatory. Obviously, if you change something, you will see it immediately because the build will break. Maybe not in your code, but it will break somewhere, or maybe just the test will break, but you should see it almost immediately. Still, it's not bad to think about the impacts, even if you have a nice CI that can tell you that you actually made an impact. It's better to prevent than to have to fix, especially because no CI is perfect and some could get through anyway. Second question is, will you ever break backward compatibility? I would say most libraries do from time to time, but you may have some very strict constraints that say that you cannot break backward compatibility at all for some reasons. Remember that removing deprecated code or features is still breaking compatibility. Even if you deprecate something and 10 years later you remove it, technically speaking, you broke backward compatibility. Some people still can call you and say, hey, my code used to work, what did you do? So even if you rarely break backward compatibility, you need to distinguish between breaking changes and non-breaking changes. Finally, an important question is, do you want to let the option to your user to hot-swap your libraries in production? What I mean by that is mostly for low-level critical libraries like, for example, like say OpenSSL. There is a critical bug in OpenSSL, for example, let's say, or some very low-level library that you published. You might want people to be able to just hot-swap the binary to get the fix and not recompile everything that depends on it. Because, well, if your security advisory well, I join a little message, I say, yeah, we know about it, please recompile your whole system to fix, you might get some angry calls. Of course, if you are a header-only library, that's not an option because you have no binaries, so people will have to recompile their code anyway. So if you answer that you have to do it, you also have to monitor ABI change because that is what defines binary compatibility. So in general, what you should keep in mind is first, be careful when you change the API. Even if you can patch all your clients at once because they belong to the same repo, it's still important to know what you are doing and what are the possible effects that it will have. Of course, if binary compatibility is necessary, you also have to watch for ABI impacts. And finally, it's very important that you inform your users when you change something. Changelog is one of the options. I'll talk about more in the rest, but if it's just you change something, even if it's non-breaking and you don't tell people about it, you will also get angry calls. People like to be warned, or at least have a way to find out that something has changed. Because when you think about it, versioning is communication. You communicate as a maintainer to your user that something has changed in your software. That's the basic role of a changelog. For the rest of this talk, I will only consider what I call reasonable use. That's something you need to determine when you start your project, what you consider reasonable use of your library, because if you want to be 100% binary and API compatible, it will be a nightmare, because there is like no limit to what kind of quirk people can try to do with your code. So some of them in this talk are not the focus. For example, line numbers. I've not seen it, but I've heard people talk about it, that some people expect the line number to not change because it should break something on their code. I will not cover that. Symbol addresses and being able to get them. The fact that, for example, it's always a given that you can take the address of a function in your library. Some people might be able to do that every time they want. The problem is if you add an overload, then suddenly there is an ambiguity and that's a compile error. You may want to say, no, that's not a use case for my library. Don't pick the address of my symbols, please. The real types of auto-types. The point of having an auto-type is usually that you say, OK, I return an auto-type which will fulfill that concept or this concept. And no, I will not guarantee you that it's in practical something with like 10 template arguments in the signature. No, it's just an auto-type. The concept is what I assure you. I will not give you guarantees about the real type behind. Do not try to find the decal type with your compiler and then put it in the marble in your code. Don't do that. And finally, the layout of private members, because some people get creative and say, well, it's not because it's private that I cannot access this because casts are a thing and whatever. Again, not my problem here. OK, so first, changes in the API. What's an API? I guess, well, who is not familiar with, no, the other way around. Who is familiar with the idea of an API? Yeah, almost everybody, of course. So basically, I like to consider that as a contract. It's a contract between the maintainer and the user. The maintainer says, OK, if you, the user, you provide me this and that preconditions, then I will guarantee this and that post conditions. It's a two-way binding contract. If the first part does not respect the contract, the second part is not entitled to fulfill it. An example of a definition of a contract that you probably have all seen is, for example, a reference of the STL on CPP reference. In this case, it's std swap. First thing that you see in the contract is its name, like the name of the symbol or the name of the thing, the type possibly. Not everything is a symbol. The name you have to use. Then there is the location of the name, which is which header you have to include to find it. And already you can find that, technically speaking, C++11 broke API compatibility because it's not in the same header. So you could get a compile error from people who just included algorithm and it's not there anymore. Then you have the definition by itself, which is basically the return types, the arguments, and the possible alternatives if there are more than one overload. You have some extra preconditions. For example, in the case of swap, the first type must be move assignable and move constructible. The second type must be swappable. And then you have what I would call the past conditions, which is what the contract guarantees if everything I said before is met, which is you call swap with 2 arguments and you respect the precondition I give. Okay, I guarantee you that I will swap those 2 members and this will happen. No question about it. So when you look at APIs, I like to categorize them on 2 types, which is internal, external. Internal is what the compiler today, I mean today because that might change in the future, but what compilers today can see. Things that trigger compilation error if you change them. For example, if you change a name, well, symbol not found, something won't build. Change a signature, most of the time, same thing, cannot find a suitable function for that call, compile error. And finally, declaration location, well, cannot find the definition, the declaration, compile error 2. And then there are the more tricky ones, which are not today possible to express in the language until we get maybe contracts or possibly concepts, which are the precondition, past conditions, and miscellaneous guarantees you can take. So since not everything is today part of the language and so part of what the compiler can see, you have to rely on some sort of documentation to tell people what are the extra things that you guarantee. I will not cover which kind of documentation because that's a big subject and not the point of this talk, but you have to do something. Like, for example, we have the C++ standard, we have the CPP reference, because if you look at the headers, for example, the description of CD swap is maybe not enough to see all the preconditions or all the post conditions. You must find at least comments, if not something else. And of course, I advise caution if you change something that's not covered by the language itself, because that could possibly be a silent change, something that does compile but does not behave the same way, which, as we will see, is very nasty. So, 3 types of changes, obviously. The most breaking, the most violent is the API breaking change. It's change your code or something bad will happen. If you're lucky, it won't compile. If you're unlucky, it will compile, but not do what you expect in production. Those are the things you must watch with the most attention, of course. Then there are the non-breaking changes, which are backward compatible. You can still compile your code against it, fine. Everything we did in the past will still will work the same. But we also added some new cool features that you might want to try or might not. It's up to you. We don't, we guarantee that we did not break whatever you could use in the past. And finally, there are some changes that, when you change your code, do not impact the API at all. Let's start with this one, because they are the most simple ones. It's simply you did not add, you did not remove, you did not change any contract in your API. Nothing from what the user can see has changed. So basically, you change the implementation. And you change the implementation in a way that does not have an impact on the post condition or any guarantees you might have taken. So for example, you may fix a bug, you may improve performance, or you may simply refactor internally your implementation to maybe regroup some code or use a different private library. Many options are there. Of course, in C++ terms, this means you did not change a name, you did not move, you did not change a name, you didn't change a signature, you did not move something from one header to another, because that would also possibly trigger a problem. You keep the same defined behavior. And that includes complexity, iterator validity, all the things that you guarantee but cannot express today in the language. So also, then you can have non-breaking change, which is new cool stuff you add that have no impact on existing users. Most obvious is adding a new function. You can add a new function, all right, that's not a problem, it's just a new thingy, it's fine. Adding a new overload, Yeah, most of the time it's okay. There are a few exceptions to this. For example, if you add a specialization, like a new overload for a specialization of previous arguments by pointer or constref, the compiler will prefer this one to the previous one for certain cases, and that might change the behavior. So you have to watch for this. Also, if you add a new overload that with the implicit type, implicit conversion rules is preferred, like the funny bool two-pointer cast that we seen in a few talks today, that could be a problem. You can add a new type, and you can add a new namespace. That's fine. You can also, what I would say, relax an existing contract, which means you guarantee new stuff that you did not guarantee before, or you add new options that are not that are compatible with the previous ones. For example, if you add a new parameter, optional parameter to a function, but that the default value triggers the same behavior as before, it's not breaking change. It's still behaving the same. You can just have the choice now to use the extended version with extra arguments. You can add a new struct member. Most of the time, there is a specific on that I will cover later, but most of the time you can add a new struct member. It's completely transparent. You can relax some precondition. For example, in the past you said that you can only take a positive number, and now you say, okay, I can take any kind of number. Well, any number is also any positive number, so it's fine. It will work. You can narrow the postcondition, just the opposite. In the past, you said always return a number. Now you say I will always return a positive number between 1 and 2. Well, technically speaking, a positive number between 1 and 2 is any number. So it's just more precise, but it's not breaking. Code will still function. You can narrow the guarantees too. Like in the past, we guaranteed that the performance would be n squared. We improved the algorithm, now we guarantee that it's going to be n log n. Well, I think nobody will complain about that. Unless you have a very specific code that rely on the fact that that algorithm has to take some time for some reason. I don't know, because you're like mining Bitcoins and you expect that it will take 10 minutes to generate one. If you start generating one in 1 minute, some people will complain. But other than specific case like that, that rely on the fact that some algorithm is excessively long, well, it's okay. And finally, you can always define undefined behavior, because it's undefined behavior and people should not have relied on that. There is lots of talk about this. I will not cover it today. And of course, that leads us to the breaking changes, which are, for example, changing a signature. If you change the argument types, if you change the order of the arguments, if you change the return type, if you rename the function, well, we all know those. Usually, it should trigger a compilation error, because things are not the same as they were, and the compiler is unhappy. Moving something to another header file, again, same thing, compiler can't find the declaration, it's a problem. If you narrow a contract, which means you change the condition, but in a more restrictive sense, then you also possibly broke the API. For example, if you narrow the precondition, you say, in the past, my algorithm will work for any number, and now you say, no, I finally decided that it only handles positive number. Well, that's a breakage of the API, because people fall in the realm of undefined behavior now, while they did not before. That's a problem. You broke the API. Relaxing postcondition is the same. You said in the past, oh, that will only be a positive number, and now you can return any kind of number. Or in the past, that will only return a string between 0 and 10 bytes, and now you can return a string with 64 bytes, or 64 kilobytes. Yeah, some people might complain that their buffer was not big enough. And that's an API breaking change. And of course, if you relax the guarantees, in the past it was n, and now it's n log n, people will complain because you degraded performance, and they could have relied on that. And that's evil. All those three are evil. Why are they evil? Because the compiler cannot catch them. If you push a change into production, make a new release with only a change on a contract that's only on one of those three, it will compile fine. Some people might be brave and read all the change logs before they upgrade and see it and say, oh, yeah, I need to take a note that when I upgrade, I have to change my code. but most of them, I guarantee you, will not see it until they start selling the bank, because now your evaluation function can return a negative number and they booked order with negative amounts of whatever. I'm not saying that this has happened to me, but that's the kind of example that could happen. Seriously, don't do that. Don't do that. If you have to break the API, also break something that the compiler will complain about. Let me give you another completely ridiculous example to illustrate the point. In the past, you had a nice sort function, which said, okay, I take a vector of ints by reference, and the pass condition is that I sort the vector using a std sort. Well, I do not take guarantees on the fact that I use std sort. I took guarantee on the fact that the complexity is n log n. Okay, fine. You change the API and you say, yeah, well, now the complexity is factorial n. Technically, you did not lie. You did not hide the change. You just say, hey, I changed the API. I made it in the change log. Why are you unhappy? Well, because you use bogus sort instead of stud sort. If you don't know bogus sort, it's a very fun algorithm. That's actually the optimized version of bogus sort, because it tries to see if the array is already sorted. So it has actually a best case of 1, well, n technically, instead of factorial n in any case. But joking aside, yeah, that's the kind of thing that you want to avoid. The real cases will be more subtle, but that's the same idea. You say, I didn't lie to you, I changed the contract, that's fine. Yeah, no, it's not fine. It's not fine, because you cannot expect people to read everything, and you want them to have like some way to say, oh, I got a compile error. Okay, let's look at the changelog. What changed? Why did they rename the function? Because it does the same thing. Okay, now I know, and I need to adapt my code. Okay. Following so far? Great. Who knows what the ABI is? Way fewer ends than for the API. The ABI is application binary interface. Basically, it defines how your C++ components, libraries, binaries, object files, and all that stuff talk together. Fun fact, it's not covered by the C++ standard. I put a star because there is a very, 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 very small part of the ABI that's defined by the standard. But most of it is not. It depends, well, technically it depends on a lot of things. Mostly the first compiler on your platform define one, and if you're lucky, the other that come after them followed the same. And usually on each platform, it's true. So again, I'm trying to divide that into two parts. The ABI part that depends on your infrastructure, your tool chain, and the part that depend on your code. The first part, basically, I will not cover it today because the answer is use the same compiler. Done. I'm sorry if it's a quick, I can give more answers after the talk, but this is about what your code impacts on your ABI, and not what your compiler change impacts on the ABI. So I will not cover it today. So what I say today is just use the same toolchain for both binaries, and that part you can just ignore. But the second part is, well, still something you have to worry about. Symbol names, binary representation of your types, well, your API types, your private types, don't care, and the layout of the Vtable. Okay, let's start with the easiest one. Who knows what mangling is? Okay, maybe 2/3 of the room. Basically, it comes back from C. The C++ still use, for compatibility reasons, the binaries talk with something that has the same architecture as the C ABI, which means in C, symbols only have a name. The type of the parameters are not part of the signature, as well as the namespace, because there's no namespace in C. So what did the C++ do? They say, okay, the only thing I can put as a symbol name is just strings, like underscores and alphanumerical characters. Okay, I'll just create a mapping function that takes my C++ symbol name and translate that into something that the C ABI can understand. I don't even know why this was a decision. I suppose it was for compatibility reasons. But anyway, that's what you get. And for example, here you see that foo int and foo double are quite the same, but not exactly the same. The signature change a bit. So as far as the linker is concerned, as far as the runtime LD loader is concerned, it's not the same symbol. It does not have the same name. What does it mean? It means that if you change any of the IDs of any public symbol in your library, any exported symbol, you break the ABI because the linker cannot find the symbol anymore, and you get a very nice pop-up on Windows and an error message on Linux that says, hey, I can't find this symbol in this library, I'm done. And the funny thing is, it's not only the symbols of your API that you have to watch. It's any public symbol in your program. And that's the fun part. Because that's something Microsoft got, actually, when they made the DLLs. They made the fact that public symbols are a thing and that you have to explicitly say, that symbol is public, I want to export it. Unix, on the other hand, just say everything is public until you tell me otherwise. So it's much harder for most programmers to tell by just looking at some code what's public and what's not. Unless you have to do with both OSs and you have probably some funny macro like myExport or whatever that's generated by CMake or whatever, and that resolves to nothing on Unix and on the decal spec import or export on Windows. And that's good, because with that you can just use grep to find what are actually the public symbol of your library. The other option is to use like nm, objdump, or whatever to just look at your binary and look at all the symbols. Because look at this example. We say that the part of the API is the part on the bottom, like the function foo. It's just a function. It takes void and it returns void. Okay, that's the API. And then internally, which is not part of the API because it's internal details, it calls a function, which is in the first case called bar, in the second case called bar2, but with one extra argument. Technically, you didn't change the API, you just change internal details. But since it's header only, or maybe just it's inline, and you call a symbol, well, that symbol is public. It's not public in your API, but it's public in your ABI. So if you rename it and you add an argument, Mangling says that's not the same name, and since that's not the same name, that's a compile error because the compiler cannot find the symbol. So you do not only have to watch your API functions, you also have to watch any public functions. Like I said, if you have any kind of export macro, at least you can just look in the diffs when you review a change list. Every line that changes something that starts with myExport or something, say, oh, that's an ABI breaking change. If not, well, it's a bit more tricky for you to figure out if you did or not. Then you have the Vtable. As you know, Vtable is how virtual functions work. And even if we try to avoid them more and more in C++, they are still a thing, and we have to deal with it. And basically, the standard does not say how it works. Well, it says how it works in a general term, but it does not give implementation details. Each compiler can do what it wants. Most of the time, it's some kind of a jump table that's attached to each type that says for that method, you just jump to that address to get the right implementation. And that's it. Of course, since it's a table, and most compilers rely on offsets and not names to find them, it means that if you reorder virtual methods, the layout changes and two binaries do not agree anymore, or what's the address of function foo in the Vtable of object O. And if they don't agree, one call will call new, the second one will call delete. That's a caricature, but you can get funny things like that. If you add a new one, that can also be a problem because the size is not the same, and depending on your implementation, you might also have some issues with that, even if that's a new thing that's not used by older code. And finally, and that's one comes from C, and I think you know probably the most known of it, it's the public layout of any structure you expose in your API. Like if you reorder the fields in a struct or something like that, you will have a problem. The reason is that the compiler, well, the compiler does, but the machine does not understand, like your struct definitions. All the compilers know is that there's this address or this offset in the struct, the size is this, and this is how I find that member, and that's all it cares about. Which means, depending on what you change, sometimes you break the ABI and sometimes not, which is very fun. And of course, the more fun it is, it's that it depends on your platform and it depends on your CPU. Depending on that, the rules say that some change in a public structure might or might not have an impact. Let's take a quick example. On this machine, for example, which is x86 64 bits, if I do a struct with one int, one bool, one pointer to a char, and one double, it will look like this in memory. That's how my compiler will translate that in binary. So first I have, at offset 0, I have 4 bytes, which is my int. Then I have 1 byte, which is my bool. Then I have padding, and at offset 8, I have my pointer. Why is that? It's because Intel says every access to memory must be aligned on its size. So you cannot start a pointer address on something else than a multiple of 8. So the compiler tries to put the fields in the same order as you gave him. He is even obliged to do that by the standard, and that's the only part that the standard covers. If it's a struct like this, it's a pod or a C struct, you have to put the member in that order. That's the only thing that the standard covers about the ABI. Everything else, compiler can do whatever they want. And then you have your double, which is also 8 bytes that you put at address 10. So if you add, for example, a short at the end, well, obviously, since it does not have the right to reorder the fields, it cannot just put it up there. It can only put at the end the size of the structure changes. And since each compiler, when you create a variable, it allocates the right size on the stack to hold it. If you try to exchange those types over two libraries, if they disagree on the size, that's going to be fun or not. You're going to get some very nasty problem to debug. Any ABI breaking change that does not just stop because there is a missing symbol, but that actually starts running like this, is terrible to debug because you're basically trying to debug two libraries that don't agree on what a type is. What you could do, sometimes, you did not hear it from me, but if you put actually the short just after the bool, alignment rules on this computer say it goes here, the size does not change, and everything that was accessed before is still at the same place. So technically, it could save your leg and not break the ABI for a critical fix. You did not hear it from me. It's more likely to bite you in the face at some point than to save you, but C programmers have known it for some time, and they may have used it in the past, but clearly not me. And I clearly did not teach you that it's a thing. Because, again, if you change platforms, if you change compilers, the rules are not the same, and all bets are off. For example, a long doesn't have the same size between Windows and Linux, which is very fun, because there is the LLP64 and the LP64, and they disagree on the size of a long. Well, usually when you do portable code, you don't use long for that problem, but you see what I mean. The alignment rules might differ, or you might use like another CPU that does not require all members to start on an address which is a member of the multiple of their size. Again, very limited case. Sometimes may help you. Most of the time, won't. So basically, if you change the order of the member in a struct, it breaks the ABI. If you add a new member, it breaks the ABI. If you change the visibility, it may also break the ABI because, like I said, all the rules about all the types in the same order came from C. So C++ is still compatible with that. But as soon as you do private blah, 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 public, blah, blah, blah. It says, oh, it's a C++ object. I do not have to live by this rule. I can do whatever I want. And of course, if you change an old C object by a C++ object by adding like a private member that was not there before, the compiler can completely reorder your struct because it thinks it's better. And it's completely broken again. So changing visibility also means usually ABI breakage. Now that we know all this, how do we version that? How do we take that into account to version our library? Actually, there are two schools of thought on that. One of them is kind of old and pretty known. The other is kind of new. But let's start with the first one. The first one is semantic versioning, and everything that kind of looks like Semver or was an ancestor to Semver, you probably know that it's the x.y.z or x.y, you know, like you put a bunch of arbitrary numbers and some dots between them, and that's your version. It has some uses. It's been along for, most software use that today. The idea is that you can have parallel releases. For example, you can create a new major, but still work on the previous one because you still need to provide bug fixes for older users, that kind of thing. It's a more complex scheme, of course, because you have like probably 2 or 3 or 4 components in the version, major, minor, patch, super major, I don't know. It allows for synchronous upgrade, asynchronous upgrade, because, for example, if you release a new version that's non-breaking, some parts of your code can link to the old one, some parts can link to the new one, and usually it works. And also, since you can handle that, it means that you can have some measure of binary compatibility. One of the uses is to solve the diamond patterns. Like for example, you have 3 libs in your project. A depends on B and C, and each one depends on a different version of Boost. If those 2 versions of Boost are actually binary compatible, you can just build the first one with we can build everything separate, and then at runtime give the latest one, and it should work. That some software today rely on that, and that's a possibility. The other possibility, since it's binary compatible, is odd fixes, like take this new binary to patch OpenSSL. No, we won't ask you to recompile everything in Linux because we have to fix a critical bug. Some library actually need that. I mean, if you have to fix something in libc, if you ask to some people, can you just recompile everything that depends on libc? It's like, okay, be right back. It's going to take 2 days, but we'll be fine. No, yeah, sometimes you need something like that. Another one that was presented more recently is the live at head philosophy that was shown at CPPCon 1 month ago. Who saw Titus' talk at CPPCon or after that on YouTube, so that I get... Okay, so I'll try to make a quick summary of what I understood from that. The idea is that it's what's been done, for example, at Google. It's that there are only serial releases. There is only one version that just increments over time. There is no backports. There is no maintenance on older version. There is only, it's just a straight line. It's not a tree. It's only source-based. There is a change. There is a new version. Please recompile everything that depends on it. Some people may disagree with that approach. It solves the diamond conflict by a simple way, which is everybody has to use the latest version done. It's possibly a bit extreme, but it can solve the problem. Because the problem of the diamond issue is that the more library you had, the more likely you get a major version conflict between 2 dependencies that you cannot solve until one of them agrees to upgrade. And if you're unlucky, both of those are third-party libraries that you do not maintain, with people who say, no, I have other things to do than upgrading, so just deal with it. I see some people laughing. It's not only me to which it happened. So yeah, that's a way to solve it. It's just, no, I recompile everything every time, and every dependency must be the same version for everyone, done. And of course, to help that, there is some points of automatic code migration. Let's go back to the first one, Semver. Everybody knows Semver? Can you raise hand if you know Semver? Oh, not as much as I thought. About 2/3 again. So it's a formal convention to express compatibility between versions. It builds upon work that's been done for years. The Semver.org version dates back from 2001 by one of the GitHub staff. I think it's GitHub. And it's basically a mathematical or logical definition of what's a version scheme. There are 3 components: major, minor, and patch. And it's quite easy. A major change is a break in the API. A minor release is a change in the API that doesn't break anything. And finally, a patch is something that does not impact the API at all. So what it tells you is that you can have any measure of code that runs on the same major, it should be okay. You can upgrade to a new minor or a new patch without needing to change your code. The problem is, since it's very generic, it says nothing about the ABI because that's a specific problem that depends on your language. But we can fix that. It's not that hard, actually. It simply says, okay, did I break the API or the ABI? Major. Did I change the API or the ABI in a non-breaking fashion? A non-breaking change in the ABI is mostly new symbols. Everything else you change in the ABI is just you work it. And finally, if you change none of that, it's just a patch. That works. It offers a degree of binary compatibility because, as we said, on the same major, the code is compatible. If you build against different version, but at runtime you use the latest one of the same major, it should work. It may also support rollbacks, which could be helpful because sometimes you don't want to wait for the critical fix if your servers are on fire. You just want to say, okay, can I just roll back that dependency, restart my server, and be up and running again without the bug? Not happens often, but sometimes it happens. And you don't want to waste 2 days with a broken version of your crypto, whatever, in production. You can also work around the diamond inheritance problem as long as the major is the same. It's sometimes a bit tricky. Package manager can help. Build systems can maybe help also. It's possible to work around. It's something that we've been doing for a long time, I think, as engineers. And for better or worse, it's the most common scheme today. Most libraries today inherit Semver or an older version of Semver. Like having a scheme with major, minor, and possibly patch is something we see in most software every day. It's even a reflex, like you put something in your method, you say, okay, it's 0.0.1 or something. It's cool. I can then increment number. And then when I think I'm cool, I do 1.0, whatever. I can even add dash beta or whatever because that's something we have in mind. That's the default choice, right? On the other hand, you can try the live at head option that Titus coined at CPPCon this year. The idea is that each change is just you increment a serial number. That you can use the date or whatever. The timestamp is just, okay, it's a new version. I push a commit, bump the ID, bump the change list ID if it's an incremental new build system, and I have a new release. Of course, you force everybody to align on the same version across a binary. And to ease things, you give at every breaking change an automatic refactoring script, something that's based on Clang tidy. Clang tools. You can script Clang. That's what Clang tidy does. For example, you can script Clang to use the AST to produce a patch after some code. To tell him, for example, rename all calls to that function to this function, and then that means automatic upgrade for everyone. It guarantees that no diamond patterns can occur. It facilitates upgrades because one of the big problems when you release a major is that psychologically, most people say, oh, it's a new major. Oh, I'm going to have to work. Maybe we can defer that for a year or 10. Yeah, I'm not the only one. All right. And that leads to problem of binary compatibility, of course. With that, you cannot. It's just upgrade, period. The drawback is that there is no measure of binary compatibility. You have to recompile everything every time. So you may want to invest on some cloud servers, I don't know. And of course, which could be a blessing, depending on what you think about it, you don't support older releases. People find a bug in an old release, it's like, just upgrade. Just upgrade to the latest after which we fixed. I don't care if it's 2 years of patches you have to take, do it. How do I include my API now that I know everything? Well, first, you pick a versioning convention. The most obvious choice today is Semver, but I think the new one shows also some promise. Then you tell clients which guarantees you offer. Like I said at the beginning of this talk, those are cases that are crazy. I will not handle them. I do not consider an API breakage if I change that. You maintain a changelog, right? Because even if you have like automatic patch, people will want to know what changed. Just maybe because it's a good way to advertise the new cool features you added, but also because it's communication, right? You change something, you want to tell people what you changed. You document your contract, because today the type system of C++ cannot do everything with that. So you have to state what are the preconditions, what are the post conditions, where do we fall into the undefined behavior realm. And finally, please avoid invisible breaking change. Avoid any change that only change the contract part and not the compiler part. For the ABI, well, most easy option is don't. So if you don't have to, don't do it. It's, like we said, it's lots of arbitrary rules, it brings toolchain issues, it brings lots of problems. If you can avoid it, if your clients always recompile, if you deploy Docker image that you rebuild every time, don't bother. Just forget about it. If your library is header only, well, you do not have ABI by definition, so it's not your problem. And I suspect that's one of the reasons why people make header only libraries today. I could not prove it, but I have a suspicion. But you make it clear in your documentation. There is no ABI support. If there is a critical bug, you recompile everything that depends on that. I will not provide you a binary that you can swap in production. Or you go for revise Semver because, like we said, Live@Head does not support binary swap, so you don't really have a choice. You have to go with parallel releases with different kind of upgrades. We don't have much time, but quickly, what about dependencies? If you have dependencies, well, if you upgrade a dependency that brings a breaking change and it's a public dependency, it's also break your API because people see that through your API, so it also breaks their code. Possibly it also breaks the ABI, so keep worrying about that. And if you change a private dependency, it breaks the ABI because people, two libraries will not talk about the same thing, they will need different dependencies, all that stuff. In the future, something might help us. For example, contracts might make some parts of the external parts, they may move them to the internal parts. It may become part of the language, which means people will get errors. You will get less and less nasty, invisible changes. I don't think contracts will cover the n-log-n or whatever, the complexity guarantee. And iterator validity, probably not either. So you will not be completely safe. But at least you can have some measure of expect, ensures, post and precondition validation. And modules, well, that depends. There's lots of discussion. Depending on how it goes, maybe people will start distributing module binaries instead of header. I don't know how it will go. I cannot tell. But maybe it will have an impact. Did you follow everything? I put out a little quiz. I hope I have the time to make it. It's fairly quick. It's like 10 questions. Let's see, okay? So, to the left is what I had. To the right is what I have right now. Let's do a show of hand. Did I break the API? Great, you followed. It's easy. I added a new type. Great. Did I break the ABI? Yeah, also too, because the symbol has not the same name. Easy. Okay. Did I break the API? People are hesitating. Did I break the ABI? Everything, everybody agrees. Yeah, I broke the ABI, but I did not break the API because technically everything that works with an int should work with a long. It's just larger, all the same on Windows. But
what if you use some detection idiom to check if it's like it doesn't have an implicit conversion, something like that?
If you have like many overloads, for example, maybe it might change the preference for example, to another overload. You mean? Yeah, that might happen. But in this case, in this special case, no. But I agree, that might be something to watch. Okay, number 3. Did I break the API? Yeah, I thought so too. And then somebody, James McNellis, pointed out that I did, actually, because I can use aggregate initialization on pods, and the order of the things is not the same. So yay, C++11 added even more things that can break the API. So yeah, technically, it's an API breaking change. Did I break the ABI? Yeah, of course, I reordered members. So yeah, I put a star. If you expect people to be able to use aggregate initialization with your pods, you break the API. If you tell them that it's not a supported case in your little preface, that's cool. You can do it. The compiler will find it. It's just names. Okay. I inverted 2 member functions. Did I break the API? Great. Did I break the ABI? No, I didn't break anything. It's just names, and hopefully the ABI is just about names, so order doesn't matter, and it's not virtual, so it's not a problem of Vtable. That's cool. The first no change that we have. Great. Okay, this one is my favorite. Before my function returned the sum, now it returns the max. Did I break the API? Yeah, I did. I'm a very bad person. I break the API and it still compiles. I'm like, what? What are you doing? No, don't do that. Don't do that. It's terrible. Almost the same, but now it's virtual function. Did I break the API? Still not. Did I break the ABI? Yay, Vtable is not the same. Okay, that's a very tricky issue, and you can answer something like, that depends on the machine. I give you a hint. Did I break the API? Yes, if I did aggregate initialization, blah, blah, blah. If not, maybe not. Did I break the ABI? Yes, if I'm not on x86, 64, blah, blah, blah. Yo, so that's a very tricky case. Maybe you can put that as an interview question or something, but you did not hear it from me again. Maybe you do not want to hire the guy who answers, yeah, technically it works, because he might do some creative things. Okay. Did I broke the API here? Well, supposedly no, expecting that the bool equals false yields the same behavior as before. Let's say yes. Did I break the ABI? Yeah, my function has two parameters now because the ABI does not care about default arguments. So it's a breaking ABI change. Okay, that one is like the easiest ever. Did I break the API? Yeah, well, no, it's not the same name. So of course I also break the ABI. Some easy one. Almost done. Yeah, 10th. Okay. Did I break the ABI? The ABI or the... Oh, okay, let me rephrase. Did I break the API? Yes, I did. It's not the same name. It won't compile. Did I break the ABI? No, the ABI doesn't care about names. So it works. Yeah, it's hard, huh? Maybe you could put the whole quiz as a as an interview. Okay, 10.5, and then I'm done. Okay. I changed some little implementation details. Did I break the API? No, the API is still the same. Well, okay. Maybe I should have put a notice. Everything that happens in namespace details is not part of the API. If you rely on it, you're a bad person, and I won't support you. That's another thing you can add to your conventions. Everything that belongs to that namespace is not part of the API. Done. So no, I didn't break the API, but the ABI, yes, because I changed a public symbol, even if it's not part of the API. It's not? Technically, that doesn't change anything because it's not because I didn't do the my export thing that it doesn't pose a problem. It's an inline function, so obviously it will be compiled by the inside and become a public simple afterward. So I heard it's nice to end on a quote. So you might have ever read sometimes some various alteration of this, which is no system became successful by breaking backward compatibility. To which I would add, especially without warning or automatic migration. I think we can all agree on that, unless you like to have very angry calls from users. Remember, communication is about, versioning is about communication between maintainers and users. So talk to your users. Thank you. I think we have like 5 minutes for questions. So if you have any questions, now is the time. Did I bore you all to death? All right, fine. It's time to head for the bar or something. Not yet. First, you have the Conan quiz, I think. Thank you all.